There's a pointer. Oh, there's lasers donuts up there. Some donuts. Oh, yeah.
Those are the donut equivalent of
The orphan just watched donuts. Orphan donuts.
All right, I think we're ready whenever.
Oh, thanks. Yeah, that's a good choice. All right. So there we go.
Okay.
Well, it's that time of year where the zonal wind direction at Palestine, Texas in balloon launches reverses from westerly to easterly every early April. April 4th or April 6th is a traditional day. It's amazing how well that works at maybe 32 north as an iconic reversal of the wind direction. But it affords us the opportunity to look back in time over this past winter. I'm just going to look at since January 1st to the present and revisit what the northern polar vortex looks like. In the past, so we've done this about maybe once a year, every year for a long time. I think we missed last year, but sometimes we focus on things such as the south polar vortex and ozone loss associated with PSCs. Sometimes we talk about dynamics. In 2013, 2014, there was the big blob of warm sea surface temperatures, and it led to an exaggerated anticyclone in the upper troposphere in the Pacific, and it seemed to be related to disturbing the polar vortex, and it was related further to persistent lobe of cold air over the eastern United States. So that configuration keeps cropping up. So let's see what's happening this year. This is the North Polar Vortex 2025. And I picked this particular date, and I highlighted the date because it's, so what I do is it's pretty, well, it takes a little time, but it's pretty lazy, it's easy. So I go up to the CPC website, click on stratospheric analyses, and then go scroll through until I find the most recent set of 850 Kelvin PV analysis. So this is at about 10 hectopascal, 25 kilometers, middle of the stratosphere, and it's color-coded, so you have purples and blues have high vorticity. You think of F as dominating PV. It's F plus theta, but F is big. 1 over rho d theta to z times F, it's very large here. It's intermediate in scale for yellow, and then orange is color-coded for a tropical PV, or low F, and so it's an indicator of air mass origin. I like this particular time because it highlights something that may be used for figuring out when cold air effects occur here, which is this polar vortex is usually displaced eastward by this Aleutian high presence, and its presence is partly due to the topography and certainly due to the warm sea surface temperatures communicating with still air in the 9.6 micron ozone band, keeping it high pressure here. But there's an oscillator. This is an oscillator system. And what happens is this is displaced eastward or toward that side of the hemisphere. And then a plume of low PV air comes around. You can see the most recent one like that. Well, when that happens, this will roll up into an anticyclone. If you take tropical air and displace it forward, it'll roll up anticyclonically. But notice it puts a little dent into the polar vortex. Sometimes it just goes away and it wraps up and the polar vortex returns to being centered over the pole. But other times there's a little pinch, and we'll be able to see a couple of those events this winter. That is, I'm thinking if air comes around here and then wraps up, it'll make a dent. If it's a large amplitude one, it can split the polar vortex, but one of the properties of rolling up here would be to displace this portion of air toward the eastern U.S. And many people have been looking into the relationship between cold air outbreaks and the polar vortex, and it's a complicated problem. So we've been looking at things like how are cold air outbreaks in Madison related to the state of the polar vortex? We address these questions. How did the northern hemisphere polar vortex evolve this winter? And then we'll highlight this part. And then in general, there's still, I think, an unsolved dynamical explanation. It's not super clear what the nature of the vertical coupling mechanism is. You can think of Taylor columns, you can think of rotation imparts stiffness, and so that it's 2D quasi, 2D flow, and all filaments in the vertical, if you look down from the top, it is barotropic in the vertical. Things like that might be helpful. So we talked about this fairly recently in the Department Seminar 21 and also in Brother Watch 22, but I wanted to maybe start with this one, which is I really like these Hopkins plots. Ed Hopkins for many years would produce these, and so they're very easy for me to use. I can just go, oh, here, this is 2021, and look at that in February from about, looks like maybe February 3rd through the 23rd. It was cold in Madison, so that's the way it was then. And I thought, well, I'll digitize this data. I downloaded it and put it into an Excel spreadsheet, and so, oh yeah, that was the trace in Madison. And then I thought I'll do the correlation coefficient between this and, I just pulled out values of PV at 850 Kelvin over Madison, so just directly over Madison in the central stratosphere. So here's the temperature in Madison added on to the value of the potential vorticity over Madison in the stratosphere, which is in ochre here. That's not Airtel's, it's not ochre's PV, it's just, it's color of ochre. And so if you do the whole correlation for this whole time period, it turns out to be a whopping, oops, minus 0.008 that says these two time series are not correlated at all. Oh no. But look at this, if you look at this period of polar air outbreaks, yes, the stratosphere was unusually high in its PV overhead, and it was cold here. So it's a complicated phenomenon. They tend to happen at the same time for a pretty good reason. First, let me show you the movie with that, and we'll get into then maybe 4 slides that talk about possible mechanisms. So this is the most recent one from the State Climatology Office, and it's pretty useful. So we see that this year it was a little colder than normal at times in January, particularly January 20th to 25, but there was also something around the 16th and a little bit around the 10th. And then we returned to a little bit more normal, but it came back. So around maybe February 12th through 20th, it was colder than normal too. Let's check and see, what was the polar vortex doing during these periods of times? We'll try that. So I just put all these movies, all these individual plots together into, what is it called, plot view or something. So this is January 1, and I think I'll have to call it out because they make the printed date so small here. Look at, so this really does say 2025-0101, which is January 1, but I'll have to probably say it out loud. January 1, a little tendency for the vortex to be displaced a little bit toward, say, Maine. January 2nd. Oh yeah, look at that. There's part of the polar vortex that's over the eastern U.S. 3rd, 4th, 5th, 6th, 7th. Oh, you can see one of the streamers starting to come around here. This was from a previous one. It doesn't always roll up over the Pacific, sometimes there, and then displaces, it generally arranges itself to be over the Pacific or in the Aleutian High after a bit. So this is the 8th, more symmetric again. Look at that plume coming around, still pretty symmetric. That plume didn't do too much. Or maybe it did, look at it, sort of came all the way around to here, and sort of shoved this that way. We're up to January 18th. And so you can see there's that lobe of the polar vortex, which sometimes turns into a peanut shape in a sudden warming, is flirting with the eastern U.S. It keeps nudging closer and then retreating, and that seems to be qualitatively consistent with perhaps cold air outbreaks favored in that longitude sector. But there isn't, we could talk about it. Do you think that cold air should be right under that vortex lobe, or should it be somewhere else? A priori, what would you expect? All right, so this is February 3rd. Ooh. Yeah, look at that. So here it goes. February. So February was cold. And you can see this streamer coming out of the tropics. See that orange streamer at the top of the graph coming here and rolling up and starting to deform this into a peanut shape. A larger amplitude one might have split that off and caused a wave number 2 warming. And see, it's displaced over the eastern U.S. and it coincided with when it was cold. And it stayed there. And look how it's sort of threatening to even break again, that little dent in there. And then in March, that dent comes back. So persistent vortex over the eastern U.S., relative to normal, all this time. So we're up to, it's February 25. Okay. Now we get into the phase where if you make the mistake of accidentally thinking that this is a face, it gets really difficult. It's just, at least to me it looks like it could be a silly face, like, oh no, it's springtime, what's happening to me? The polar vortex is going away. So look at this dent. So this plume out of Africa is really spectacular. It's stronger. And see what happens with the interaction with the vortex now, like that. So we have a classic shearing off of high PV filament going around this way. Rossby wave breaking, wave number 1. And at the same time, in the troposphere, there's a wave number 5 Rossby wave breaking. It goes hand in hand. You won't be guaranteed that it'll be at this longitude, but it'll probably happen somewhere. So there's a strong basis for that perspective. So watch what happens to the vortex. All right, so we got March 10th. Here's another crimp in it from another surge like that. And then it migrated again over eastern U.S., the part of the vortex did. Look how fast these remnants are whipping around the Aleutian High and rejoining, starting to rejoin maybe. I missed that time, but oh, no, here we go. No, not that time. Finally, it stabilizes into this little nickel-shaped dot, which is still over us. And it was cold, a little bit cold. This is April 18. And so this is just the last few days that I added on last night. I guess you could imagine that in the light green, there's still a little bit of movement. You know, how you contour something and color code things really changes what you perceive, but there is this, so that seems to coincide with the idea that it just could be colder than normal, which it was this April. And now we're going to get out of it, which will be the wonderful thing for the rest of the talk today. But before I finish, I'd like to just remind us of what are people thinking in the community for that sort of process? What can explain it? What ingredients might be important in thinking about it? So this is a canonical discovery. Several different papers about 25 years ago showed that if you say have a blocking high building up in the Pacific, that information will be communicated into the stratosphere and tend to generate a weaker vortex, tendency toward sudden warmings. Also vice versa. If you have a notably high index flow in the troposphere, that'll be followed by high index flow in the stratosphere. But the reverse is also true and perhaps more robust. If the polar vortex has a sudden warming and it's all wobbly, wave number 1 Rossby wave breaking, it's actually upgliding warm air and sinking cold air in the stratosphere, which is thermally direct. It's releasing energy. That air will then sink because it's in the dark and cools. So you have the opposite downward extension. So this is the northern annular mode concept. If you know that you have a strong vortex in the stratosphere at 60 north, then for the next couple months, it's more likely that you'll have a high index flow in the troposphere. So these two states go hand in hand in the stratosphere and troposphere. Go back and forth. And it seems to be possibly related to the idea of rigidity due to rotation. And I think this baroclinic instability or thermally direct laboratory analog tank has merit. If you have salty, dense water here and pull out the partition, it'll slump, but the flow will only go so far because it curves to the right, conserving angular momentum, and causes a stable vortex, goes round and round. And down here, this is slumping outward, but it only goes so far because of the stiffness of rotation, and that's the trade easterlies. Or you could think even the polar vortex, that there's this anticyclone in the lower troposphere over the pole, and the air is diverging out anticyclonically. So this is the stratosphere, tropospheric analog. You have the jet going around, and then here's the cold coming. So it's just releasing energy, converting energy. And it goes back and forth between a state of high index flow in the troposphere and stratosphere at the same time, and sudden warmings plus cold air outbreaks in the troposphere at the same time. But you don't know exactly where they'll happen. Like this is a pretty common pathway, but things are happening over here too, and over there at the same time. And it isn't a foregone conclusion that you could just do something naive like I did and pick the point right overhead and have no lag, no displacement geometrically. I think maybe Andrea and John might have some really much better developed ideas on how to go about addressing that problem, if my intuition is right about that. The last slide is just more of a visualization of the process. So this is actually ozone, and my advisor, Conway Leobi, wrote this paper. I was only peripherally involved, but I think it's a nice way to view things. So this is a section of ozone along that spiral path for the top diagram. This is the lower diagram. And you can see the surge of high ozone that goes poleward around. So these events, if you look at just one level, like 10 millibars, seem like just sort of maybe a lens, but they're not. They're deep tilted sheets of low PV, high ozone, high volcanic aerosol air that goes, and high temperature air that goes over the pole. And then, okay, there's one more. This is why I gave this talk. There's an advertisement for 712. If you like this sort of process, sure, we'll talk about sudden warmings a bit, but a lot of other topics if you, well, okay, we'll go back to this. About that one. John. Yeah.
Matt, you talk about these plumes coming from the tropics, and they seem to come from the Atlantic Basin.
Yes,
What drives
Africa,
those things?
or yeah, sometimes the Atlantic, Africa, Middle East sector.
Yeah.
It's very, very common, and I think that's a target of opportunity that's not very studied.
I was going to ask you if you have some intuition or some results about that, but you're recognizing it yourself as something that's not well understood
like
yet?
in 1992, Alan O'Neill had a paper where he discussed this process quite a bit, and I did as well with a paper with Lynn Harvey in 1996. Some people have kind of, I don't know how much people are paying attention to this, but maybe not many.
Guys, that's really interesting. I mean, it's compelling that you see these things go around and then anticyclonically roll up over, Atlanta, Alaska, Bering Sea area. Yeah, that's really interesting.
I knew about that part, but then I just realized, oh wait, if it happens in a certain way, it puts a dent in the vortex, which displaces it over us. In certain patterns.
Yeah.
But then translating that to an actual cold air outbreak, that's dicey. Like that correlation coefficient was 0 for that whole time. Maybe in certain subsets of time it could.
Yeah, but that seems like an okay thing to do. I mean, why not think of it that way? I think that's a cool way to think of it.
All right, maybe this summer we'll make some progress on that.
I think it's really neat.
Michael, do you want to?
Yeah, if you could go back to that time series you were showing of
This one?
that one, no, it was the one that you showed the PV and
Okay.
temperature.
This is from 2001.
Right.
Sorry, December 20, 2020 to March 2021.
So at least within that period of, in February, where you see that sort of anti-correlation seems fairly strong.
And in other years too, there are periods that show up, and then the longer records tend to diminish the correlation.
Right. I'm wondering if that's not too, I wouldn't say it's unsurprising, but it's not too surprising because you would expect if you have this massive, very high potential vorticity over a location, at some depth beneath it, you're going to expect to see temperatures below normal, right? If it's anomalously high.
You're
you
getting
expect
at
to
the
see that.
question. I mean, isn't it appealing to all of us that there's hydrostatic thicknesses? So if you go from the bottom up, there's cold air here. So you build up through that, you're going to get to a trough, and there'll be cold air in the trough. It'll be polar air. That seems to have some legitimacy. But then we see some parts of this movie where something in the stratosphere is just skedaddling along under some sort of momentum at that level. It's completely decoupled from you.
Well,
Right.
Yeah. Oh, go ahead.
I think it might be a scale issue, right? Because a large-scale vortex that shifts is going to have a much deeper and penetration depth than something that's much smaller
All right.
and maybe
LR
more
goes
transient.
like
NH over F. And so
then the H is different for HR, then is bigger for longer wave.
Right.
Yeah. Okay. All right.
So, the depth of influence should be.
Yeah, but what I
equal
never
to scale.
get, that makes sense, but what I never get is how does it get through the tropopause? How does the impact get through the
There is a
tropopause?
node. So all this is happening here. All this is happening here. They're correlated, and there's a node of almost zero activity in between, which is really intriguing.
Yeah.
And I think you and Andy are interested. What happens to that layer in the trailing season? Because in the stratosphere, after it reverses in the mid-stratosphere to easterly, everything's all hunky-dory, rising motion, it flow toward the southern hemisphere.
Yeah.
But in the lower stratosphere, there's still a vortex. It's weak but persistent into May.
Yeah, I think
June,
that's
maybe.
really interesting. And
Not high PV, but it's there
Yeah.
in the lowest part, like 450K.
Yeah.
I didn't have time to show that, but it seems like research that like maybe some other students.
yeah, it's really neat. But I know what you're saying. Yeah, the scale helps, but I never understand how the scale gets you through the tropopause. You know, because
I
that's
don't
a pretty
know. It's a
strong
wonderment.
barrier.
And that kind of laboratory analog where something is happening at the top, conversion at the top, spinning up a positive vortex, diversion at the bottom, spinning up a negative vortex, or slowing the flow down and causing waves to amplify and disturbing the flow so you get cold air outbreaks. There's like a mutual Rossby wave breaking that happens through the whole volume. And there's a node in the middle. Yeah, awkward.
It's
Well,
interesting.
the thing is, the tropopause, I'm not sure why that's going to be considered, or I haven't looked at, obviously, this data maybe as carefully as you guys have, but why would it be a barrier? Because
It's pretty slack C-shaped. It's not real sharp like in the tropics, but it is a region of.
Right. You get that extra boost from, to the extent that the signal exists from 850K down to, let's say, 400K, right? Then you're encountering the lower stratosphere, upper troposphere. If that signal is still there, and you also have high PV there,
Yeah.
then the stratification drops off, and that
Yeah.
gives you an extra
Easier
deeper
to get
penetration,
down.
right?
Yeah, yeah. I guess that's right. That's a good point. Yeah,
Oh,
that's a good
in
point.
the upper troposphere where the static stability is low, you anticipate a deeper penetration because
Yeah.
M
So-
is smaller.
Yeah, so I guess that's a good way to put it, and my question was a little bit different than,
Okay.
I said it the wrong way. How do you go from 10 hectopascals to 100 hectopascals, 800 Kelvin to 400 Kelvin? Is it only when the circulation's coherent through that depth that you get this anti-correlation, maybe?
I don't know. That could be
That might be
a
what's
possible
going on.
aspect.
Because then, what carries on from that is that, yeah, you put that kind of vortex on top of the poorly stratified lower stratosphere and even more poorly stratified troposphere, it's easy to communicate that circulation from there. But how do you get it from 800 to 400? Maybe it's got to be coherent. And how does it get that way?
I don't know.
That would be a cool test
Maybe it's a
map.
mode of Rossby wave breaking.
Yeah,
In
what
at
if
the
you...
top, out at the bottom.
What if you took this time series and you had some measure, I don't know what it would be, but some measure of the coherence or the depth of the coherent structure, and you kind of painted it across this time series, and there are times where it's not coherent, suddenly it is. Every time it is, that's where it's anti-correlated. That might be the way
Could
it
be,
actually goes,
could
right?
be. There may be certain configurations that are related to the moderate negative correlation
Yeah.
periods of time.
Yeah, that's cool. So I know what you're saying. Yeah, I said the wrong thing. You're
Well,
right.
thanks for giving me the opportunity, this sort of fun stuff. Maybe somebody can do something with it. Just some ideas.
Thank you, Matt.
Okay. I think we can all agree that we haven't been able to shake the cold air. Seems like we warm up and then 3 days later it's cold, and we warm up and 3 days later it's cold. Just what's happening today. We get a warm up and now we're back to cold. But this is a look at the week-long IR loop. I'll just let this run and point out a couple features of interest. Once it restarts, you'll see we had a gigantic trough over the western United States. That slowly progressed over the eastern United States. You'll see here's the trough. You can see it in the cloud features. Spurred up a lot of convection. Once it moves from the mountains over the plains, we get a cyclonic development. This was Sunday, Easter Sunday, so the Easter bunny was wet, delivering the eggs. And then we were sort of in this, we had another cyclonic development on its heels, but then we warmed up, and it was a really nice week. We had some mornings where convection would fire over the plains, it would slowly drift towards us. It would be rainy, and then it would be sunny. And it's April, so the sun angle is pretty high. We got into the 70s for a couple days in a row, so it was pretty nice. But today, unfortunately, as you'll see at the end of this plot, there's another short wave that moved over us. producing cloud cover, it's gonna get in the 50s, but because we don't have the high insulation, the cloud cover, we're gonna stay pretty cold relatively today here. So you'll see, it'll be more obvious in the upper level charts, but there was a wave that moved from Canada producing our cloud cover here. So we've been in a very summertime-like pattern where after that trough moved, you'll see there's not too much in the way of synoptic level flow. It's mostly just zonal. You can see that, the clouds moving over completely zonally. We have convection firing over the plains. This is typically like June weather. Yeah, that's all I want to point out for this loop here. Oh, and then one other thing that's pretty obvious, you can see, here's the subtropical high, and it just persists over this entire period. What's that doing? It's pumping all the warm, moist air into the central plains, and boom, there you get your convection. Especially where it's been 80s and 90s over Texas into Kansas here. So that's stayed, and that looks like it'll continue to stay here. Maybe producing severe weather for us early on next week, which I won't touch on. But we will touch on, I just personally won't do.
Right. Another interesting thing is that spin in the Atlantic, and on the eastern side of that, you can see as the convection dies off, you can see the circulation, the cyclonic circulation kind of breaking away in the low clouds.
That's right, yeah, you can see it, yeah. And I looked at the charts going back, this was completely a low-level feature, like 850 and below, so that's interesting as well, yeah. Yeah, you can see it becomes like a skeleton almost. You can see the swirl, low-level clouds, but here's the convection, here's the cyclonic motion there. Could we go to the current satellite, please? There's a couple interesting things we can point out. So that was the week-long loop here. We'll get the current visible. All right, so what you can see, it's basically a mess of clouds for much of the eastern United States, aside from the western United States. It's not really too coherent, but we'll point out some things here. You can see speckled cumulus developing, especially over the southeast. We're in this thick, more stratus type cloud cover here. Some dying storms over Oklahoma. You can see taller clouds become, the rain is literally dragging the air down, and you get outflow boundaries, and you can see that. A couple of them moving from Oklahoma down into Texas. These can spur convection because you get rain cooled down air, you still have warm moist flow, that creates a boundary, and all of a sudden you get more convection right along these. It doesn't look like it's happening right now, maybe some over Mississippi here, but for the most part you can just see it in the cloud features here. Pretty interesting, we have a lot of just stratus-like cloud cover. One thing I want to point out too, we're talking about Canada and how snow-covered it's been. We need to shake some of the snow cover so we can get persistent warm air. That's slowly happening. As you can see, we now have more of the ground not snow-covered. All this speckled up here is snow cover, and then this portion of Canada, the southern plains of Canada, is now becoming more clear. That's evident from the satellite loop, but you can also see where we have snow cover. You would think as nighttime happens, we get a lot of cooling. An inversion might form. Where there's no cloud cover, that inversion is not as strong. You get cumulus developing. So you can see that pop up on the periphery of where you have snow cover, really cold air. Even within this snow cover, there's a region right here that spurs up. But where you have the snow cover, you're not going to get that as quickly. So there are a couple things evident of that this is snow cover, not just clouds. You can see the warm, moist flow from the subtropical high, persistent. And then what's looming in the distance, which might be our severe weather maker here, you can see a trough beginning to make its way over California here.
Looks like really cold air on the back side of that
Yeah,
thing too. Those
absolutely.
open cellular cells are quite impressive even at an oblique angle, and they're moving
Yeah, and they go-
rapidly southward.
Exactly, they go all the way down to Baja, California, essentially. So, yeah, very cold.
Can we look at the goes west?
Oh yeah, let's pull that up. We'll do the.
Yeah, it's kind of got a kind of weird. I didn't bring it to class today because of that.
Oh, okay.
I thought it might be.
Could we pause it? It's just
Flipping
a bit-
back and forth
Yeah.
between east and west.
We'll just pause it. This is perfect.
This is like
Here,
tariff
you can see
policy
that.
in the video.
Here's your trough. You can make it out in the clouds here. So the open cellular convection, this is the really cold air deep within the trough. And then on the downstream side, it's a trough, so you're going to have weak but upper level ascent. You get more significant cloud development here. This seems to be the only large scale wave. We're looking from California all the way close to Asia here. And this is the main player, aside from something near Hawaii here, maybe a cyclone there, but this is a pretty large disturbance in comparison, it seems. Okay, could we go to the radar, please? We'll just look at that quick. We'll see if any of those clouds are raining. I don't think it's raining over us. I haven't been outside for a while. I think we had a chance, but right where Madison is, the radar is not picking up significant rain. You can see here's the dying thunderstorm over Oklahoma, and there was one out ahead of it, producing that outflow, and it does look like maybe it's producing convection on the outflow boundary as you get that return moist flow, but for most of the eastern United States, it's just rainy. Nothing too intense in terms of the reflectivity scale here. And then the west is dry, we saw that pretty obviously here. And then there's the beginnings of the trough making its way on shore there. And it looks like, I don't know for sure, but the main rain band as of right now has moved to our east. Redeveloping too, it seems right over Milwaukee, which is interesting. Could we go to 250 now, please? We're going to take a look at the jet stream level, and we'll see something interesting.
250?
Yes, please. So here you'll see going all the way from Alaska through the United States into the Atlantic. We don't really have that two jet streak, not model, but we don't really have two jet streaks, which we've had when we've had really cold air into the winter months. The jet's becoming unimodal, and Libby Orr has done work to show that this is right around the time this happens.
Yeah.
And when that does, we get in a summer-like pattern, and that's exactly what's happened over us. And you can show this at other levels. I'm not going to for the interest of time. But you can see we're beginning to have one jet, essentially. This is maybe the only subtropical and polar distinction is off the Atlantic. Over us, though, largely just one incoherent jet. But one thing to note, we'll see this going down, but here's our shortwave that's moving over us, producing general ascent out ahead of it. And you can see maybe there's another one in the Central Plains. Right downstream, we saw all the precipitation and cloud cover, so that's exactly where you'd expect. There was cloud cover over the Central Plains, wasn't producing any, the radar wasn't picking up on any reflectivity. It was all out ahead of that trough. Maybe there's two or three embedded, but they're weak at this level. Could we go to 500, please, now?
Yeah.
So we'll go to the little lower, look at more of the trough ridge pattern. You can see here's your really cold air, very deep trough, making its way over the west. We have zonal flow, we've had that for a while. That means warm for us, generally, but you'll see here's a shortwave coming right out of Canada. With it, pretty significant cold air advection. You have temperatures around minus 30 in Canada, down into the minus teens over us. So this is decent cold air advection subsidence, but keeping us cloudy and cold here out ahead of it. And maybe this is your other shortwave feature. Although it's very incoherent, that might be a function of we just don't have data anymore for much of this part of the country. But it does make sense too. It's not coherent. We didn't really see a nice cyclone. It's just generally clouds and precip out ahead of it. But here was our summer. A really nice weather is now over the coast, and now we have what we haven't been able to shake. System coming out of Canada, keeping us cold, and then a potentially more significant system making its way over us. But there's potential to warm up. If you see a ridge over western Canada and most of the west, you think this is just going to translate towards us. Produce generally sunny skies. We saw that over much of the mountains, and so if it's sunny, nice sun angle, we should warm up and stay warm. So hopefully it'll warm up going forward here. And there is some slight warm air advection within this ridge feature, so maybe it'll build a little bit. At least maybe it'll maintain itself, and we can be the beneficiaries of the warm weather underneath it here. And then could we go to 850, and that's the last spot I'll show here. And so something to point out here, here's your subtropical high. I didn't point it out at the 500 millibar level, but you couldn't see it. And so here it is at 850, so it's a low level, lower tropospheric feature. Here's the anticyclonic flow, but that brings a lot of warm, moist air. You can see dew point depressions are relatively small. They're 4, 3, 2. It's warm. Temperatures are 16 over us. We have decent cold air advection. It's 2 degrees at 850 in Minneapolis versus 12 middle Illinois. So here's your decent baroclinic zone, producing that, some mechanism for producing that precipitation, but what's going to mostly happen over us is just going to stay cool because we have that nice cold air advection at 850. Here's your ridge, not as warm as what's down south, but it is warm relative to what we're under here. And you can see a nice gradient in the moisture too, where we have, here's your warm moist air from the Gulf of Mexico, and then this station here, which is southern New Mexico, is 22. The dew point depression is 38. And so this is extremely dry air. It runs into really moist warm air, still warm, less warm, but a portion of it is going to subside. It'll spin up some vorticity, and you get continuous convection, which is what has happened. There were pretty good tornadoes last night, and I think a couple days in a row now in this part of the world, Plains and the panhandle of Texas here. Because we've just set up, we have really dry air coming off the desert into warm, moist tropical air, and that hasn't moved. Nothing's come through and moved this setup. And it seems like the feature off the west is going to be what's going to do that. Although I'm not 100% sure, I was just guessing.
So the radio sound station just north of Brownsville, it's not Corpus Christi.
I think it is Victoria or Corpus Christi.
Yeah.
Corpus Christi. It has a dew point depression of 11, but
Yeah,
the ones surrounding it are much,
Yeah,
much
that's a
lower.
little
I'm
curious.
with that.
I'm honestly not sure, yeah.
Could be an error. That's one of the variables that sometimes, I guess, they report can be in error, but I don't know if that's the case yet.
Yeah. It might also be mesoscale, something going on. There was some convection, but it does seem erroneous as you have, it should be pretty moist. I mean, I always look at like Corpus Christi. If it's ever warm here, look at Corpus Christi because they have temperatures like 100 degrees over 85 all the time. And it's like 120 heat index persistent for 3 months. And so it puts it into perspective. Yeah, it's warm here, but
Could be
I don't
worse.
even know how people live here.
Yeah.
Like I sweat when it's 60 degrees outside, so imagine
I know.
120 every day.
Yeah, I can't stand it.
It's terrible, yeah.
Yeah, just like a forecasting note, Patrick, I love on these big plots when we forget often about the scaling of the F in the geostrophic wind calculation. If you look at that station just south, like in Brownsville, it's blowing, what, 20 knots?
Yeah.
With the pressure gradient looking like it is. And you go up to Hudson Bay, also blowing
Yeah.
20 knots, with the space
Oh,
in
good
the
point.
isobars is dramatic. I always run into that problem when I
Good point.
get a call to forecast something in like the Caribbean. I'm like, oh, it looks like it'll be light.
Yeah, look at
No.
yeah. Like, it is
Yeah.
20 knots
A
right there,
terrible
yeah.
time to sail upwind
Yeah.
near Cuba.
Good point, yeah. Great point. It also might be, I don't know if this is true, but a function of data missing too, but it's definitely that scaling well.
Yeah.
I agree. Anything else anybody wants to see before I turn it over?
Thanks, man.
Okay, thank you. This will be rather brief. If we go to the, I think it's the last tab here, set up just about snow cover. Patrick showed nicely on the satellite imagery over the last several weeks how we've been seeing the creeping of the unsnow covered area, the ground beginning to reappear as the snow has melted. We still have in the analysis here significant snow depth all the way up into central Canada and eastern Canada. And I think that's probably one of these reasons that we've been talking about over the last several weather watches, that we can warm up a little bit if we get a nice strong southerly flow, but once the flow slackens, the pressure gradient weakens, and we get the surge of cold air southward, it kind of just chills off rather quickly. And so snow cover, persistent snow cover is probably one of the key factors, I think, in our not being able to maintain a long string of several warm days. So just see how that actually
Yeah,
evolves.
so the trade-off is, you wanna stay cool in April and not smoky in June.
Right, that's right.
You know, I don't mind the cool in April.
But these areas dry out here, you get the fires later on.
Yeah.
and the smoke. Let's go to forecast and quickly just look at the outlook, since we're gonna be brief with this. First of all, we'll look at CPC outlooks, then we'll look at SPC, and then briefly the surface evolution. So this is the 6 to 10 day outlook for temperature. You can see we're kind of in this, much of the eastern or northern part of the United States. East of the Mississippi is gonna be normal to maybe slightly below normal, particularly parts of Michigan, again, from the snow cover locations. But there is warmth around us, which is great. It won't be nice if it were over us. So if we go ahead to the next period, 8 to 14 days, looks like we finally begin to lose some hold. Again, the deeper the red doesn't mean it's necessarily much warmer, it just means more likely that it's gonna be warmer in these regions. But maybe we're beginning to see a shift in the pattern and maybe some of the melting of the snow up in Canada. If we go to the precipitation outlooks for 6 to 10 days, again, we're gonna be dry, or likely dry, and then in the southern part of the United States, above normal precipitation. We see this persist into the 8 to 14 day link as well, affecting much broader area of likely below normal precipitation during this period. So if you like warmer weather, maybe that's coming in drier weather, perhaps as we go on average in the next couple of weeks. Let's also go back to the forecasting over to the SPC outlook here, and just a very quick review of things. The likelihood of some severe weather and thunderstorms over parts of West Texas and the Panhandle still is maintained today. Things begin to relax a little bit as we go into Saturday and Sunday with just general thunderstorm activity, maybe enhanced risk of greater probability of severe weather over parts of Nebraska. But I guess the big thing that's people beginning to focus in on is on Monday into Tuesday, early Tuesday morning, the possibility of some severe weather over the upper Midwest, particularly over Iowa, western Wisconsin, and southeastern Minnesota. And so that's something that I've seen plots, that we should probably add these links to our Weather Watch links, from a number of different products that people have, whether it's AI generated, this is SPC, done manually, but a lot of areas being focused in on parts of Iowa, southwestern Wisconsin, sort of a bullseye beginning to form of likelihood of some severe weather during that period. You can go to this page, or more likely go to the SPC page to get the stuff, the actual discussion, but there are discussions that are attached. I don't know if it's shown down here, if we scroll down a little bit. Yeah, of course, this takes us to the SPC page, but you can see discussions on why the likelihood of this severe weather is occurring. But we're going to bypass that for today, but obviously this is your source for that data. If we go back to Pivotal, we'll just quickly look at the evolution of the surface maps to round things out. The 2 minutes that remain. You can see, it's at 6 hours, the forecast here is the light precipitation that's occurring. Remember, we have that upper tropospheric trough that was moving through our area. If you look at the diagonal tropopause maps, you can see a nice, very thin filament that's going by. You don't have time to do that. But the nice thing is, as this weather system moves further to the east, and let's go ahead to 18 hours of the forecast. Again, that cold advection comes in, or as you can see, temperatures dropping back into the 30s overnight tonight. But that sets us up with strong cold advection, as well as a beginning to see more of an anticyclonic flow over us. Cloud cover is going to diminish, and looks like as we get into Saturday, we go to 30 hours of the forecast tomorrow, just in the early afternoon. As people say, big bubble, no trouble. Big anticyclone over us. It looks like we're going to have some fairly decent weather. Winds lightening up a bit, so it's not going to be so breezy that it feels cool, and temperatures, according to Moss, get up to about at least 58 for tomorrow, after a low of about 36. This ridge continues to the east, sort of tracking along with the cold advection. We go ahead to, let's just go ahead a full day in advance, please.
Oh, yeah.
There's a ridge over us, and then the warm-up begins with the southerly winds beginning to to return to southeasterly winds, if you're looking at including the effects of friction, southeasterly winds, and getting us into the mid-60s on the day on Sunday. Since we're skipping some of these maps, there are some showers that are expected to develop on Sunday early in the morning, and then they kind of just fade off during the day as that warm convection begins to set in. And so this is going to be a rather warm day on Sunday. And if we go, on Sunday, showers in the morning, and then things begin to clear up. Let's go ahead to the same time on Sunday, Monday. And this is just before the severe weather outbreak, I guess, sets up for us in the to our southeast. But again, really strong warm advection and some light showers with a fairly intense cyclone over parts of western Minnesota. If we go ahead just 6 hours on that.
Oh, yeah, here.
Okay, here's the beginning of the thunderstorm complex as we get into the overnight hours. This is a little level jet begins to rotate, but to our area. So that's, I believe this is the outbreak that's possibly being informed by the forecast. One other thing I'd like to look at is just the dew points. This is kind of neat. I'm not sure if this is the right time for this, but this surge of really moist air from low latitudes finally just sort of surging northward. These are, if we could get rid of this or scroll up just a little bit more to see what we're looking at in terms of the range. These are dew points in the 60s over us as we get into Monday afternoon and Monday evening. So that's going to be a pretty warm, moist day. And then if we go even muggier, dew points actually will go off in the 70s. But dry air is not too far to our west, and once that cyclone moves further to the northeast, we're going to see the wind shifting. We'll get back to some slightly cooler weather, but certainly drier weather coming up. So weekend looks decent. The rest of the day just cloudy, kind of cool. Tomorrow, sunny, winds diminishing, and temperatures in the upper 50s, and then we get to Sunday rather. Sunday's going to be a really nice day, warmer with some showers maybe in the morning, and then really nice Monday, feeling almost like early summer with some high dew points and the threat of some severe weather in the afternoon. So that's it. Thank you, Matt, for a really wonderful presentation, as well as Patrick for the current weather, and Pete for running the whole
And
show.
thank you, Michael. That was really good today.